-2 here if you want, just to show it's gone down 2 units. This second one, if it's minus fx, that's a reflection in the x-axis. Okay, so you think all the y, remember fx is the same as y, so it's just saying all the y values are now negative. So if the y value previously was up here, it's now down here, so that's a reflection there. It should have the same intercepts. So that's something you might have got wrong. They should have the same intercepts. Okay, next one, how to factorize this. So factorize, we open up 2 brackets. We are thinking, right, what 2 things multiplied give 7x squared? The only thing is 7x and x to give 7x squared. And now we think about factors of 16. Factors of 16, we've got 4 and 4, or 8 and 2, 16 and 1. I think 4 works. How do I know it works? Well, I check this little multiplication, which would happen if I were to multiply these 2 brackets out. 4x, 24x, 28x, sorry. And I know I need to make negative 24x because that's the middle term here. So that has to be negative. This has to be positive. So the negative is with this multiplication and the positive is with it. That is the answer. You just need to factorize. That's it. Next question then, required a calculator. So we have this function. Want to find the height of the stone after 1 second. So this is a function of t and h, so time and height. So when the time is 1, I can just put in 1 for t, and it's 20 take away 4.9, which thinks that gives 15.1 without having to use the calculator yet. The next one then on the diagram sketch. So the first thing I notice here is my window would be at don't want that. My window is from negative 10 on y, 0 on x to 4.5, so I'll do that. You can put in 5 if you want, or 4.5. And then negative 10 up to 25 I already have in. So let's press y equals, clear that one out, and put in this one. We don't have a t button, so we have to use x. 4.9x squared. We look at the graph then. It should be something like this. You see that? Okay, I need to transfer that. Where does it cross the axes? It looks like it crosses around 4, so before 4.5 and starts something like this. Okay, so I keep it below. So something like that is fine. We'll put in the rest of the details when we find them. If you find more details, it's good practice to put them on the graph. So that's not the best sketch of all time, but we're going to find the maximum height. We'll put that in a second. So the maximum height will be, go second, trace on your calculator. You look for the maximum, so down to number 4 here, just press 4. To the left of it, move your arrow to the left, press enter. To the right of where I think the maximum would be here, and don't guess. So the maximum is at, so how many figures do we need to go to? Yeah, 3 significant figures is where we need to go. So the time is going to be 2.04. So the time is this axis, the x-axis, and 20.4. So we know that this highest point here is 20.4 and 2.4. That's the maximum. Okay, you should probably, if you have the information, put it on the graph. Find the length of the time the stone is in the air before it hits the ground is the next. So I want to know, this is the stone's path. It goes up, hits a high point, and goes down, hits the ground here. I think that'll be the ground level, 0. So I need to find where the 0 is. So second trace, find where the 0 is, or where it crosses the x-axis. It's going to be right down here. So I move my bounds down, press enter. On the left bound, go past it, press enter again. On the right bound, in between those two, the 0 is at 4.08. The last question is the tricky one. Find the length of time. It's more than 18 meters above ground level. There's a couple of ways of doing this, but the easiest way, I think, is to just put 18 meters on my graph. So if I had something here, a line here where the height is more than 18, I would know that between these 2 times, it's more than 18 meters. So I'll use that. How do I draw that on this graph? I just press y is equal to 18 is the second line. And when I graph it, I should see that line I was looking for. I want to find where these two intersection points are so I can go between them. I press second trace and I look for intersect. I put my dots around the 2 points of intersection. So enter, enter, enter. That's the first one I found was 1.34. So I know that this one is 1.34 seconds. I'll find this one next. Do the same process, second, intersect, go over to this one. It's not the quickest process, but 2.74. So I go to 3 significant figures here, and then I subtract those two. So I think I get, is it 1.4 seconds? Subtract those two, 1.4 seconds. Subtract these two numbers you got on the graph. Okay, moving on to question 4, another graph. So set your window, either first or second, but definitely set your window to what is written here, -2 and 7 for x, and -6 and 6, -6 and 6 for y. Then I'll type in my function, clear out the old ones, press clear. This function, I need lots of brackets for this, so I'm going to put the x plus 2 in an extra set of brackets. What's it, an x? That's all to be divided by, no, divide. Didn't need the x plus 2 in extra brackets, just this one need an extra brackets. X minus 1, x minus 4. Make sure you have them both divided, otherwise your graph will look a bit weird. When I graph it, I hope to see, yes, okay. I get this shape, which I can sketch in and then put in any other information. So I'm looking at it. Before I sketch, I know there's asymptotes. I want to get those correct so that my sketch does not overlap any asymptotes. So I'm actually going to go down to these 3 asymptotes, just to be absolutely clear. I can work out the asymptotes from the denominator here. If x is 1 or x is 4, I'm going to get 0 in the denominator. But the other way of doing that is by doing the table. And, someone scrolled the whole way down to 100 here. If you scroll all the way up on the table, you can see what this is going towards. This is going towards 0 on the y asymptote. So that's that one done. And you can kind of see that from the graph as well. What line is it tending towards? 0. It's getting closer and closer to 0 as we scroll down. Whereas my 2 errors for the x ones, they're at 1 and 4. So x equals 1, x equals 4, and y equals 0. So if I scroll down again, I'll get to 0. So I'm going to just use those to draw my graph. So if I go back to my graph, I just want to make sure I don't cross x equals 1. So I put it here. X equals 4. There's my 2 asymptotes. And then I'm going to put a sketch in between. So now I can do my sketch a little bit more accurately. And there's no crossing of the asymptotes. Should draw those with a ruler, of course, but I didn't. To find the coordinates of the local maximum, that's just a calculator skill. Of course, the maximum of this graph is at infinity. It goes up forever, but there's a local little maximum turning point here. That's the one they want to find. That's why it's not the maximum of the graph. It's the local maximum. So I press maximum on my calculator, and I go left and right. Enter, enter. 2.24 on x and minus 1.94 on y. Okay. Next bit asks us to solve this equation where they equal the original equation. So where they equal, I can do that graphically by drawing this second equation, which is just x minus 5, x minus 5. I have a little look at what that looks like. Oh, we got this line coming across here. Where are they equal? They're equal at 3 points. 1, 2, 3 points. I'm just going to sketch that on this just so we have it. We have to find those 3 points. Maybe I'll find one of them and someone can tell me the other ones because it's going to take me all day. Find the first one. Just go on the first curve to, just looking for this one first. Press enter. Second curve, just do it around the other side of it. And the intersection is 1.34. Can someone tell me the other ones? What's the other two? 2.79 and 5.78 or something, isn't it? 8.7. Okay. Mira, are you working hard there on your laptop? Thank you. Okay. So how do I solve the inequality where the f function is greater than the g function? The f function was the curve function, the original one. Where is it greater than the g function? In a bunch of spots. All here, between here and here, and up to here. There's 3 places it's bigger. When it's bigger, it's above. How do I say that? Well, before the asymptote, it was bigger. So when x is less than 1, between these 2 points it's bigger, and we have these 2 points here. So x between 1.34 and 2.79. And also from the asymptote up to this point, it's bigger as well. So from 4 up to 5.87. Okay. That's that one.
Why do we measure from an asymptote?
Just because in this case, you can see that between here and here, it's less than. So where's the point it picks up again that's more than? It's right before this asymptote. It's not equal to the asymptote, so up to, like this goes on forever up here, but it's definitely above. So it starts at 4, starts at this mark, up to this mark, from here to here. Okay, so question 5, our first composite one. Sub in f to be 3, so we get 2 times 3 minus 7, which gives minus 1 as an answer. Solve it equal to 1. Leila, you good? Solve it equal to 1. You add the 7 over, and I think x will be 4. Getting an inverse, we swap the x and y. So first of all, I write it like this. I swap the x and y's, 2y minus 7. Then I solve for y, so I get x plus 7, and then divide by the 2. I get x plus 7 over 2 is my inverse. Find this composite function. So this means sub g of x into f of x. So g of x from above is root x. If I sub it in, I get 2 root x minus 7. So I just replace the x with root x, and that's just the answer. Solve this equal to 5. The same thing, equal to 5. So maybe add 7 to both sides. We worry about the square root at the very end. Divide by both sides 2. I get 6. So what number square rooted gives 6? Or you can square both sides. I get 36. Either way, I get 36. Next one, find f into g into h of x. So start with f, sub it into g of x, and if we do that, I think we get the square root of 2x minus 7, if we sub that f into g of x. And then if you sub that into h of x, which is 1 over x, that becomes 1 over this. It's only a 2-mark question, that's okay. Leave it like that, it's fine. Okay, moving along, question 6. Very small type, sorry. We sub in minus 3 into this, we get 5. So you double minus here makes it positive, so that's 5 plus 6, which the answer is 11. Get h of 2. So what's h2? h with 2 in it is 2 squared minus 3, which is 1. And then sub that answer into f. So 1 needs to go into f. So f with 1 in it is 4 times 1 plus 2, which is 6. Next one, find f or x when the function equals negative 10. So we have this function, and it equals negative 10. If I solve this, then I subtract the 2 over, I get 4x is equal to negative 12. Divide by 4, I get negative 3. Write down the range of h of x. So h of x is x squared minus 3. That's that function. What's the range of this function? If you wanted, you had the calculator so you could sketch it, but maybe you know in general that the x squared function goes like this. And if that's translated down 3, it goes like this. So this low point here is at minus 3, which means the range is the y values, these values. The range will never go below minus 3. So in other words, the range is y greater than or equal to minus 3. So it's always going to be above minus 3. Minus 3 is this bottom point here. You could look at that in your calculator as well. That's okay. To just check what's the lowest point, and then it's all above that. Getting an inverse again. So y is equal to 4x plus 2 for fx. Swap the x and the y. You solve for y. So I think if I divide by 4, I have it. X minus 2 over 4. Next one. Describe a single transformation that maps gx to kx. So let's just have a look at gx and kx. Gx is something. 5 minus 2x over here. And this new kx is 10 minus 4x. Now we have to notice what the relationship between those two is. And I notice that I can, if I factorize this a little bit, I get this. Oh, no. I get 5 minus 2x in the bracket here. So if I factor 2 out. So kx is gx just multiplied by 2. So what's that? If I multiply by 2, what's that as a scale factor 2? Yes. And what would I say it is? Vertical stretch. Yeah, vertical stretch.
What if we just are multiplied by 2?
No.
Wait, why?
How do you know it's a vertical stretch?
Yeah.
Okay.
The rules.
We did do this transformations. We looked at it. So if there's a multiplier in front, so kx is twice gx. So that's gx. So this multiplier in front here, that a number, whatever it is in front, would be a vertical stretch. Anytime. Yeah.
So transformation is very good.
Yeah. So functions. Yeah.
But it's only after a stretch, right?
Yeah, yeah. Or no, the translation. If it's adding afterwards or subtracting afterwards, the translation. Or in here with the x, it's translation as well. Any stretch we're looking at is this multiplier in front. Okay, this second one then, the graph of hx. So hx we have up here is x squared minus 3 is translated by this vector 2, 0. So what does that mean? That means to the right 2, doesn't it? To the right 2. So how does that affect this function? That means instead of x, it's now x minus 2. Translation to the right 2 is this effect on the function. So instead of x, it's x minus 2 squared minus 3. So this x becomes x minus 2. They want it in this form, so I got to actually multiply it out. X squared minus 4x plus 4, if I do this out properly, fully, and then subtract the 3. And I get x squared minus 4x plus 1 when I do it. So I had to notice that this is a translation to the right 2. Translation left or right affects the x. Remember, in the opposite way to maybe what you think. To the left would be plus 2, to the right would be minus 2. Okay, so that's probably technically maybe the trickiest question, maybe. Okay, let's continue on. Solving this. This looks like a quadratic. It's just not written in the usual form. So I'm going to add the 2x over and subtract the 11 and let it equal 0. I'm not sure this is factorizable. Is it factorizable? No. Okay. So if I can't factorize it, there's a couple of ways I can do it. I can use a calculator. It's a calculator question, so I can actually just draw it. It'll be U-shape, and hopefully it'll cross the x-axis at 2 points, and I can get the zeros for that. Or I can use the quadratic formula, which I will use. That's A, that's B, that's C, I can use minus b, so x would be minus b plus or minus b squared minus 4ac all over 2a. So I do that, x equals minus b is this 2, so that's minus 2, plus or minus 2 squared minus 4 times 8 times negative 11, so ac, all over 2 times 8. Not a particularly nice one. Negative 2 plus or minus, I know it's over 16. I need to figure out what all this is. Someone surely has this worked out already. Was it all equal? Brilliant. Yeah.
So is the whole test calculator?
Yeah, if there's any particular question I don't want to use a calculator, I'll say it. 356. What's the square root of 356? Is this squared? It's not a nice number. Oh, yuck. All right. Well, let's continue anyway. 18 point. I did it all in the calculator there. 18.6796. And then I just add. It probably was easier to draw it. But anyway, how do I finish this question off? I need 2 answers. So I do negative 2 plus my answer from above. So second answer, if you're not sure how to do that. Gives me an answer, and I divide that then by 16. I get 1.05. 1.05. And then if I do negative 2 minus 18.6, whatever, or 18.8679, and then divide that by 16 as well, I get a negative answer, negative 1.30.
Sir,
Yes.
so if you did this on a graph, it would just be the 2
Well, let's see. Let's plot it, clear these out. Let's draw it. 8x squared plus 2x minus 11. Graph it. There's it. I want to find these 2 zeros here. Second trace, 0. Left bound, I'll only do one of these just to make sure. That one and that one, enter. So I get 1.05, which is what I got here as well. So much easier to do it on the calculator than the quadratic formula, I think. Next one, use graphical methods to solve this. Was this a problem or is this okay? Okay, so let's have a look. I'm going to use my graphic calculator again, use graphical methods to solve it. So I'm just going to graph x cubed. I'm going to graph 3 to the negative x. And we see where they equal each other. Okay, so that's x cubed, that is that curvy function. And that's negative x. Okay, we're looking for this point. We're looking for where they cross over here. So how do I find that? Press second, trace, and go down to the 5, intersect. I think it only has 1 point of intersection. Somewhere here. Enter. That's it. Not minus, 0.758 rounded.
Sir, does he get all 3 marks to draw the graph if I just write the answer?
Yeah, okay, it's asking you to I didn't see this, the second part. Yeah, it asks you to sketch the graph, so you don't need to, you can just sketch what you see. Something like that. Very quick sketch. It's fine. Okay, completing the square with no equal sign here. So can we complete the square with no equal sign? It's all about taking this middle term and halving it and squaring it. So 10 halved squared. I'll show you why we do this in a second. So that's 5 squared, which is 25. How does this help us? Well, we need to fit in a square here, a perfect square here. So what's the easiest one to fit in? It's the one that involves this middle term that we already have. And so the perfect square involving this middle term will be actually x plus 5 squared. Where'd the 5 come from? Here. Because when I square this out, I'm just doing rough work over here. You never have to show this, but x plus 5 squared is x plus 5 times x plus 5, which gives x squared plus 10x plus 25. So you see what's happened here? This is the 25 I've created, and 10x is already embedded in this square. But I've added a 25, so this 25 has just come out of nowhere. So what do I need to do to balance this equation? I need to subtract 25. Because when I multiply this out, I get an additional 25 that's come out of nowhere. So I subtract 25. I still have this 14 here at the end, but now that's the exact same equation. Because when I multiply this out, I get this, and then I subtract the 25, I'm just left with this bit, x squared plus 10x. All I need to do now to finish this is x plus 5 squared and combine these two to minus 9, minus 11. So the 25 I did here is the number I subtract, and the 5 here is the number I put in the bracket when I'm trying to complete the square. Yes, Anissa? It's possible, yeah.
It doesn't say for every equation.
The only difference is if there's a number in front here, you'd have to divide everything by it first. You'd have to, well, factorize it out first. Factor out the number first. Yeah.
But is completing the square like going to be on our like end of year exam, or did you say it was an IT skill in class?
It's a skill at this level. You won't get an A in front. So to be able to do this much is fine. So what did I do? I took this term, I divided it by 2, and I squared it. So 10 divided by 2 became 5, and 5 squared is 25. That 25 I end up subtracting, and the 5 ends up here in the bracket. Okay? And 5 minus 11 is the vertex of this equation, the HK. Okay, on to the last page. Then I'll let you guys do your revision or ask some further questions. All right, so if I sub in x plus 2, my answer is minus 11 into this. So with x plus 2 in becomes 7x plus 2 minus 4, and that equals negative 11 when I sub it in. And I have to solve this equation. Probably the easy thing to do is just multiply in by the 7. I get 10. Subtract the 10 over. Do I get 7x is equal to negative 21?
Yes.
And x then will be negative 3. Okay? This one of these indices type questions. So 5n, that's 1 over 125. We want to get that same base. You want to get 5 as the base. So 125 can be written as 5 cubed, I think. And now, if I want this above in the numerator, I can just change the sign to minus, and I can write it like this. So n must be negative 3, because they're equivalent. In this last one, I have a division of indices. 32 is not written as 2 to the power, so that's the first thing I'm going to do, actually. Excuse me. 32 is 2 to the power of 5, I think. Dividing indices, what must I do with the powers? Dividing, I subtract the powers, yes. So I can just write it with one base with these. 12 minus k over 2 is equal to 2 to the power of 5. Now this must equal this, because they're both equivalent. That's equivalent to that. So I can just write that bit. K over 2 is equal to 5. And then I can solve this like an algebraic equation. Maybe have